Hey, I thought we'd have a little bit of fun today and go through an implementation of FizzBuzz in a test-driven style. FizzBuzz is a game for kids to teach them a little bit about maths. So essentially what you do is you get kids round in a circle and you get them to each say one number in order from 1 to 100 or when everyone's out. And what you have to do is you have to say, shout the number by default, and then if you get to a number which is divisible by 3 and it's your go, you shout fizz. And if you get to a number which is divisible by 5, then you shout buzz. And if you get to a number which is divisible by 3 and 5, then you shout FizzBuzz. And if you get it wrong, you're out. And what test-driven development is the red-green refactor cycle. So how this works is we create a failing test and we try and do the minimum amount of work possible till that test passes. And then we look and see if the implementation is sensible, if our tests are telling a good story. There are a few other names for this this style of development. And the one that I particularly like is example-driven development. Or example-driven design, because I think it really describes what we're going to be doing. So the first thing that we're going to want to do, and jump over to my IDE, I'm going to create a test which talks about the most simple example. So the most simple example is that I input 1 and I get 1 back. So let's run the tests. Okay, the tests are failing. So this is our red. So now let's do the minimum amount of work that we can do to make this test pass. Cool, so the test's now passing. But there is a little bit more to this example than to this particular case than is necessarily shown by this example. So what I like to do next is I quite like to add in another example. So we're still in this test, the default number is returned test, because that's the sort of rule that we're implementing. But because this 1 doesn't quite encapsulate all the behavior of this rule, we're going to put in another assertion in here. So if I put a 2 in, I should get a 2 back. Okay, so we've got our failing test again. So let's just read this through. Let's read this test through and make sure that it makes sense. So test by default, the input number is returned to standard out. And it failed because the right number wasn't returned to standard out. So a big part of why we like to run the tests in our first step and see them fail is we can read through the test, read through the description and make sure that it is accurately describing the example we're trying to articulate. So we're kind of trying to tell a story to future developers to help them understand what exactly we're trying to do here. So in our case, we're trying to create an example which shows that by default the input number is returned. This also has a second advantage. So I don't know how much you know about accounting, but in accounting you have balanced ledgers. So you essentially do the maths twice. So the maths on one side has to match the maths on the other side. And what this means is that you have a way of checking that your code is working. So by failing the test, we get to see if our examples are making sense, but we also get like validation that both sides of our ledger are correct. So we know that we are quite unlikely to have made a mistake either in the test or in the code itself. Okay, so let's implement this. So if I remember correctly, it is format exclamation mark. Let's do this. Okay, so let's try making this test. See if this test passes. Okay, cool. So I think we've probably got enough for this particular example. So let's move on to another example and try and drive out a bit more of the logic that we have here. Okay, so let's take this. Okay, so what are we going to do now? So what we're going to do now is we're going to add in a test which says test with a number divisible by 3, we get fizz back. Okay, so let's get one example for this and drive out. You'll notice that I'm only writing these assertions one at a time, rather than writing a whole bunch of them. I'm just writing one and then doing the minimum amount of work to get that passing, and then expanding on it if I need to. Okay, so 3, and we should get fizz back from that. Okay, so let's run the tests. Okay, cool, we've got a failing test. So if I then go if input equals 3, now remember I'm doing the minimum amount of work here to make the test pass. Oh, got to string. Always forget that. Cool, so the test passes, but this is a bit of a silly implementation, right? So let's add in another example to help drive out a bit more of that behavior. So another example of this would be 6, right? We should get fizz back for 6. So if I run the tests, and now my tests are failing, so I've got a nice failing test here, which allows us to go into it. Okay. So let's just make this nice and simple. So if modulus 3 equals 0, and then let's run the tests. Cool. So both of our examples are working now, which is really cool. But there is a little bit more that we need to do. So I've talked a little bit about the red phase and the implementation phase where we make that test go green, but I've not really talked very much about the refactor phase. And I think this is a good opportunity to do that, because one thing that I really dislike here is this input modulus 3. It's not very clear what it's doing. So let's take this out. So let's extract a method from it. Oh, it doesn't work in Rust. So let's extract a method from it. So let's do return, let's do input modulus 3, modulus number, and instead of input we're going to do number, because I've changed the names of the variables. Divisible by 0. So why is this unhappy? Ah, I forgot to put in a return type. Okay. So let's go and slip this in here, and you can tell that I'm refactoring here with relative confidence, because actually what I'm doing is safe. We have tests to guarantee that this is, I'm not going to break anything by doing this. We have plenty of examples. So let's do this. Int is divisible by, and then put input in. Number is divisible by 3, and our ID gives us a nice readable little string there. Okay, cool. So let's run the tests again. Cool. That was nice and simple. So we've gone through and we've refactored the code. So we've been through a whole cycle. So we've seen the test fail. We implemented the minimum amount of work to get it done. We refactored where we weren't happy, and then now we're going to write another failing test, and this time for 5. Okay. So if let's have a look at what we're writing here. So with a number divisible by 5, we get buzz back. So what we're trying to do here is we're trying to guide ourselves into the smallest possible code to implement the logic that we need. So I'm gonna see the test fail again. Okay, cool. So we expect to get buzz back, but we've got 5. So let's add in a new clause here. Okay, and the test pass. Now, I have an interesting question. Could I change the code and make this test pass, but have the example still, have the example not be fully implemented? Could I make this test pass, and could I break my code without this test failing? So, although we've got the test passing here, there's something that's worth noting that because we didn't go in the smallest possible step in this instance, I can actually rewrite this code. I can go input 5 and still have the test pass. And what this means is we haven't got a rich enough set of examples in our tests. There is software which will do this automatically called mutation testing, and we'll go through and check if your tests are actually covering all the possible cases and your examples are good enough. But in this case, the best sort of guiding rule of thumb is that if you could choose between 2 bits of code, one which is simpler, always go for the simpler one, because the last thing you want to do is make your code more complicated than it needs to be, because the problem space is complicated enough. Okay, so let's add in another example to fix this problem that we've identified. So if I go through and change this to 10, and then rerun the test, we should see the tests fail. Fantastic. So if I go and then change this to back to is divisible by 5. Now we have a more accurate exploration of what that rule actually is. Okay, so it's time to add in the final test, the FizzBuzz. Okay, so if a number is divisible by 15, we get FizzBuzz back. So let's get rid of that. And then change this to FizzBuzz. Okay. Now, one thing that we can do is we can go through and we can make this change. We can add in 15. Okay, so our test passed, that's cool. And now I'm going to add in another case just to be a bit more happy about how we're driving this out example-wise. Oh look, so something interesting happened here. The test passed first time. Now, if you're actually doing TDD in a pretty serious way, this doesn't happen very often. However, it does happen. So what do you do if your tests pass first time? Now, the important thing to do is to check that the tests actually work. Because remember before I talked about how this was balancing a book, so we want the equations on one side to be sure that those are working, we want the equations on the other side to be working. Okay, so if I do input equals 15, so now we can see that the code is working just as well as, we can see that the test is working because we've now seen it fail. So it's very important to see the test fail every single time. And we can, while we're here, have a quick look through the name of the test and make sure that it makes sense. Okay, so if I just put back the code, I don't need to keep it there because I know that it works. Got the tests, both sides of the code are balanced. The other thing to think about when you're going through this is, do my tests make sense? Are they nice and clear? Are they as clear as they could be? So your tests are code which is just important as the rest of your application. So it's very important that you keep it as clean, because these are going to be the documentation that, like, when you come back to your code in 6 weeks time, 10 weeks time, when you're looking at it going, oh shit, why did they do that again? That is where you're going to need these tests, particularly for like nuanced of implementation detail. So I find test-driven development or example-driven development or example-driven design to be a very, very powerful tool. And I certainly wouldn't start a project without launching off in a test-driven way. And I hope after watching this that you feel the same way. I really like it as a technique. Yeah, so that's test-driven development. I hope this was interesting and useful.